So on we go. As we have said, we are past our basic programming, algorithms and data structures, and object-oriented programming courses, and we are now starting our Introduction to Computer Vision and Deep Learning course. Everything in Python and everything done to end up processing images about forests collected by drones, which is our main focus in this course. In this part of this initial part of this first computer vision unit, we will be speaking about what computer vision is, and most importantly, we will be speaking about what images are in computer vision. Computer vision is just a part of computer science that tries to teach computers to see, to interpret visual information, to see as humans do. So in order to learn a little bit about computer vision, we need to think just for a second about how we perceive things, about how we see things, because that will be the basic to how images are defined in Python in computer vision, and very particularly in the OpenCV library, which will be our main library for image manipulation in this course. Basically, our visual perception amounts to light bumping off objects in the real world and ending up in our eyes. Our eyes then take this light, this reflected light, and process it, and then send signals to our brain that constructs a map of the world around us. So light impacts on objects, bumps, ends up in our eyes, and then our eyes transmit this information to our brains so that our brains can make a representation of what the real world looks like, a representation that we can then navigate and understand to some extent. In order to communicate the things that we see, the things that we perceive to other people, to other humans, we have for a long time tried to represent the things that we see. So we have tried to make pictures, images, art that helps us explain to other people the things that we are perceiving, the things that we are seeing. Okay? And there are many ways in which we construct pictures, and we can go as far as prehistoric caves if we want to, and we can stop at how photographic cameras gather information and turn it into digital images. But today I want to pay special attention to images such as this image downloaded from a very interesting website, open source. Basically is what is called a puntillistic image. So a whole image, a whole representation is built by making lots of small dots of different colors. And when we put together all of those dots, we get a whole image, a whole representation of something, some visual object or some scenery, like in this case. In digital images, we are basically going to be doing the same thing. So there are many ways in which we could have represented what we see. One of them is to use points to create this representation of of the visual information that we are acquiring, so that we can then share it and explain it to other people. And in computer vision, we are going to use an approach very similar to this, using dots to represent images, to represent reality. The difference with this one is that here the artist can put the points more or less wherever they want, and in the digital images the points are going to be very, very precisely ordered. So they are all going to be in the vertices of a regular grid. So let's go into this in a little more detail. First of all, let's say that these points that we are going to be using We're not going to call them points because that doesn't sound fancy enough, so we are going to call them pixels. So pixels will be the basic unit of information in our images, in our digital images. We, as I said, are going to be placing them in a very orderly fashion. We are going to imagine a 2D grid, and then we are going to place 1 pixel in all of the vertices of the grid. So because of this, my pixel will have 2 dimensions, x and y, and every pixel will be separated from its neighboring pixels the same distance exactly in x and in y. Okay? So when we imagine a digital image from now on, we will imagine a grid that we will store using a matrix data structure, and I will speak about those in a second. Grid matrix data structure made out of pixels. Okay, and those will represent my images. And what is at each pixel? What in this case, for example, we had some color value for every point. So in the case of digital images, we will have images of different types, and these types will depend on what we have at each pixel. Sometimes we'll have just either black or white pixels, and we will call those images regular grid, evenly spaced points in 2D that are either black or white. We will call those binary images. Or maybe we'll have values, integer values between 0 and usually 255. So 0 will be black, 255 will be white, and all the values in between will be different shade of gray. So evenly spaced pixels in a 2D grid with grayscale values from 0 to 255 will be called a grayscale images. The last type of image that we will deal with are RGB images, where at each pixel we'll have 3 values: RGB, red, green, and blue, or some variation of that order, as we will see in this session. And those will allow us to represent beautiful images such as this one. Okay, so I said before, my grid, I'm going to store it in a 2D matrix. You very likely have seen matrices before, probably in algebra class, or maybe in numerical analysis or something like that. Matrices have 2 dimensions, and they are used a lot, for example, to optimize functions and in all different settings. Here, to solve systems of equations is also a very common one. Here I'm importing some functions from Python and some Python libraries, and I am using them to define a matrix here made out of random real numbers and printing it here. So matrices have rows and columns, and then they have elements that we can access by indexing their x and y positions. Okay, so you can play around a little bit with this code. Also, in terms of data structures, for us, matrices will be lists of pixels. Okay, so if we have a binary image, we will end up with a list of lists of values, integer values, which are either 0 or 1. Or if we have a grayscale image, we will end up with a list of lists of integer values that are between 0 and 255. And finally, if we have an RGB image, we are going to end up with a matrix with a list of lists of values that have at each position a tuple of 3 values, which correspond to the RGB color. And each of those is going to be also between 0 and 255, which I hadn't said before. Okay. Now, in the next video, we are going to be speaking about how to create some nice images using this matrix form and see how the two work together.